notion of how do you call it? Notion of set builder notation. The notion of a set builder notation last time set is usually called it set builder notation. I showed you in an interval form that if you have something like this, let's say -1 and 1, depending, if this is, let's say, a full dot, then you write that this is the interval from -1 to 1, right? And I also showed you that if it's open, let's say here is -1, here is 0, and here is 1. Let's say if it's open and 1 and then close here, that means it's -1 and 1 close. Just a second. Sorry for the interruption. Please let me know if I read the seven minutes. So I said, you see, if you have it in this form, so it means that with this open, it means that's half open. And if you have it like this, let's say -1 open and then 0, 1, you have it like this, that means that it open both sides. So you write this interval as -1 to 1, right? That is in R. However, and the same if you're doing it. So however, I didn't show you how to use, I showed you the set builder notation, but in a slightly different way. So the set builder notation is, let's say, if I have that interval -1 to 1, how do I write it in a set? In a set builder notation is going to be the set of x element of R, which we don't write, such that -1 less or equal to x less or equal to 1. Then if I have -1 and 1 open, then this is the same as writing it in set the builder, the set of x in R, -1 less or equal to x less than 1. Then this notion, so let's say if I have it, let's say from 1 to infinity, then you're going to have it, let's say, as a set of x such that 1 less than x. This will less than x less than infinity is enough. However, you can also write it just like x strictly greater than 1. That should be enough in to say. So the same in the same fashion, if I have it, let's say 0 to, let's say 3, with 3 open, then you can say is the set of all x with 0 less or equal to x less than 3. Then if I have it in this form, let's say 0 to infinity, then it's going to be the set of all x element of R, which we don't write, with x strictly greater or equal to 0. That is a way of writing the set. This is, so the one in the curly bracket is what we call the set builder notation. So in a similar fashion, if you have it, let's say negative infinity to 0 close, or maybe let me have it as 0 open, negative infinity to 0 open. Then you say is the set of all x. The builder notation will be set of all x with x strictly less than 0. So I guess now you should be familiar now with the, so then in a similar fashion, if you have it, let's say a to b, so you can just have it in this form. You say a here, let's say b is somewhere here. It doesn't matter where they are in this, and this is closed. Then this is just x is in between a and b. So x is in between a and b. And then if you want it in a set builder notation, is they say the set is all x of x between a and b. So that should characterize for all of them. All right. Any questions on set builder notation? Because now, based on this, we should be able to now define what is a piecewise defined function. And then not only that, so if someone give you a graph, just from the graph, you should be able to determine, let's say I give you a graph here, and then let's say here this is A, then maybe somewhere here this is B. So from this, you should be able to see that the higher, if this is, okay, so this is the highest one. So from this one, you should be able to know that the x value here is, let's say, alpha, And then the highest X value here is, let's say, beta. So this should give you the domain. The domain is, let's say, from alpha to beta. The domain is from alpha to beta. And then you can also pick up the range from B1 to B2. So the range will be from B1 to B2. So this, just by looking at the graph, you should be able to understand that the range is from B1 to B2, and the domain is from alpha to beta. Okay, is it 7 minutes already? Let me cut it. Hopefully that is 7 minutes. If it's not 7 minutes, then we'll have to get it sorted out in a 7 minute. Okay,